Okay, this is a question about amino acids and polypeptides. There are 4 sections, A through to D. Pause and try each of them, and then when you've given it a go, review your answers with the rest of the video. So here's part A, part B and C, and here's part D. Okay, so going back to part A, taking a look, we've got the data book to help us, and there are lots of useful structures in there related to this topic. But actually, this first question is much more straightforward. Although it's in a polypeptide question, it's basically asking you, what is a hydrogen bond and how is it formed? And it's always that we have got an electron deficient H. And remember, it's when an H is bonded to an N, an O, or an F, which will make it very delta positive because there's such a difference in electronegativity. Now, because the electron deficient H exists, it can attract the lone pair of electrons on the O. And you can see 4 examples of that in the diagram that's been provided. Moving on to B and C. Well, B is asking you to consider what is happening with cysteine. And it's important to note that this diagram that I've just put on here and highlighted is provided in the data book. Now, what you've got to do is try to work out where that cysteine structure fits in. And what's missing is this section here. And then finally, you have to show that there is a sulfur-sulfur bond. So, good bit of revision of all of the key facts on this topic will make a question like that quite straightforward. Similarly, for part C, the type of bond in part B between 2 polypeptide chains, it influences the 3-dimensional structure of the protein. What type of protein structure is it? That's tertiary. You'd also have got the mark if you had said quaternary. And then finally, moving on to part D, we need the structure of the Zwitter ion of a dipeptide formed by alanine and serine. Again, let's just take a look. Alanine and serine are both provided. So I'm going to start by drawing both of those out. And what you can see once I do that is where we're going to lose an H2O that's going to allow my peptide link to form. So that H2O goes, and I end up with this structure. You can see my CONH in the middle. Now, if you've paid attention to the question, you will know that this is not yet finished. And that's because we are not asked to show the dipeptide, we're asked to show the Zwitter ion of the dipeptide. So once we've got this, the Zwitter ion will exist where the COOH loses its H, and the NH2 gains an H. So we end up with this.